Have you ever sneezed as a result of inadvertent inhalation of air dust? Then, are you aware that it could be due to air pollutants?
Air pollution kills an estimated 7 million people worldwide every year. The World Health Organization or WHO data shows that almost all of the global population, approximately 99%, breathe air that exceeds the WHO guideline limits containing high levels of pollutants, with low and middle income countries suffering from the highest exposures. Moreover, global CO2 emissions declined by 5.8% in 2020. However, despite the said decline, the global energy-related CO2 emissions remained at 31.5 gross tonnage, which contributed to CO2 reaching its highest ever average annual concentration in the atmosphere of 412.5 parts per million in 2020, around 50% higher than when the Industrial Revolution began. But did you know? Concrete's common binding agent, as one of the common widely used materials in the building infrastructures, accounts for contributing 80 to 90% air pollutant emissions on an environment and roughly 7 to 8% of global CO2 emissions. KNKR2 aims to provide a solution that would address this problem by using photocatalytic self-cleaning concrete, which also sequesters carbon.
Wait, what is photocatalytic self-cleaning concrete?
Just like the name itself, photocatalytic self-cleaning concrete provides the self-cleaning ability of concrete surfaces by retaining their light color for longer, along with the property to remove airborne toxins, particularly nitrogen oxides. It works by adding a catalyst to the fresh concrete mix, which has a white color.
Hmm, how about its ability to sequester carbon?
Well, here comes the magic ingredient, titanium dioxide. What is titanium dioxide, you ask? It's a white powder that amplifies and brightens white opacity because of its exceptional light scattering properties. Not only that, it can also double the carbon uptake of conventional concrete when it is added in the cement paste to be used in the design mixture. This is in fact supported by a recently published research conducted by Lizancos and their team. Talati and their team also found that carbon sequestration not only addresses the environmental problem but also aids the global CO2 emission. The trapped CO2 is compactedly stored and will not easily be released into the atmosphere, and this will serve as additional support to improve the concrete's compressive strength. Also, a large percentage of carbon dioxide emission in the industrial processes can be traced back to the cement production process. But 43% of the emissions from 1930 to 2013 were reabsorbed in the natural carbonation or carbon storage process of cement. Now, what if that number was doubled?
So, are you planning to create concrete with that?
Yes, KNKR2 provides this solution to address environmental problems that affect us a lot. I mean, just imagine a concrete that can clean itself and even the surrounding air of harmful pollutants. This is what the concrete made with titanium dioxide can do. The function of this concrete is to break down harmful pollutants in the air via a reaction catalyzed by light, or photocatalysis, due to the titanium dioxide that is mixed to the cement during its production. This was inspired by the ability of certain microbes to break down harmful chemicals by modifying their oxidation state, also through photocatalysis. According to the study of Mora and their team, nanotitanium dioxide produces an improvement in the CO2 uptake until a certain percentage. This maximum percentage depends on the exposure age and water cement ratio. Nanotitanium dioxide produces a reduction in porosity and an increment of calcium hydroxide reactivity, which have opposite effects on CO2 uptake. These two competing mechanisms may explain why nanotitanium dioxide can be beneficial or detrimental for the CO2 uptake as a function of water cement ratio and age. Titanium dioxide was also selected due to its superb ability to kill bacteria, significantly higher than other chemicals like zinc oxide. Our team proposes that ACI will conduct research about photocatalytic self-cleaning concrete. The ACI Committee on Research and Current Development 123 will further examine the potential of this concrete. The ACI will formulate a new committee under specialized application and repair that will focus on self-cleaning concrete or assign an existing committee that is related to the topic. The same committee will be supervising the creation of the ACI standardized code for self-cleaning concrete. Following the ASTM code for aggregates C127, Portland cement C150, and a combination of SCMs C595 or C1157, the committee will develop a new concrete mixture design with titanium dioxide mixed in the cement, by also utilizing recycled coarse aggregate or RCA to reduce extraction of virgin materials. The committee will examine the effects of the added material on the mechanical properties of the concrete using standard ASTM testing, including compressive strength ASTM C39, flexural strength ASTM C78 third point loading or ASTM C293 center point loading, tensile strength ASTM C496, and modulus of elasticity ASTM C469. Other related testing will also be conducted such as lump ASTM C143, concrete mix proportion ACI 211.1, curing ASTM C31, aggregates grading ASTM C33, air content by pressure method ASTM C231. This solution can also address 6 important Sustainable Development Goals of the United Nations, such as SDG 3 Good Health and Well-being, SDG 9 Industry, Innovation and Infrastructure, SDG 11 Sustainable Cities and Communities, SDG 12 Responsible Consumption and Production, SDG 13 Climate Action, SDG 15 Life on Land, and a very timely innovation in this time of pandemic.
Oh, now I see.
Who knows? Photocatalytic self-cleaning concrete can be the future we all have been waiting for.
Photocatalytic self-cleaning concrete. Always clean, for the future is green.